Hi, welcome to Grade 5, Lesson 15. Our learning target for today is I can solve real-world problems involving area of figures with fractional side lengths using visual models and/or equations. For today, you will need Lesson 15 problem set. So let's get started. I'm going to start with question number 1. Question number 1 says, the length of a flower bed is 4 times as long as its width. If the width is 3/8 of a meter, what is the area? So they told us that the width of the flower bed is 3/8. So I'm going to start off with my little model here. My width is 3/8 of a meter. The flower bed, the length is 4 times the length of this. So this is 4 times greater, but we don't know what that is. We don't know what the length is. But in order to find the length, they told us that it's 4 times as long as the width. So in order to find my length, I am going to do my 4 times the width, which was 3/8. Now I'm going to go ahead and multiply. Since the 4 is a whole number, I'm going to put it over a 1. Still didn't change the value, but now I have fraction times fraction. 4 times 3 is 12. 1 times 8 is 8. I have an improper fraction, so I'm going to change that by dividing 12 divided by 8. 8 fits in a 12 one whole time. 1 times 8 is 8. 12 minus 8 is 4. So it fits in one whole time with 4 as a remainder over 8. Now 1 and 4/8, the 4 and the 8 I recognize are both even numbers. So whenever you have a mixed number, you'll want to always simplify to lowest terms. Now I know that 4 and 8 can be both divisible by 2, but I have 2, 4, 6, 8. I know 4 fits into both of these, so I'm going to divide both of these by 4. So that will leave me with 1, and then 4 divided by 4 is 1, and 8 divided by 4 is 2. So my length that I found turned out to be 1 1/2 meters long. So that is my length. So now I have to find the area. I don't know what the area is, but now that I have my two pieces, I have my length and my width, I can go ahead and find my area. My area, length times width, my length was 1 1/2, and my width was 3/8. Okay? I'm going to change this mixed number into a fraction. And I do that by saying 2 times 1 is 2, and 2 plus 1 is 3. So I have 3/2 times 3/8. So I had changed this mixed number into an improper fraction. So now I'm left with numerator times numerator, so 3 times 3. So my area is equal to 3 times 3, which is 9. 2 times 8 is 16. So my area is 9/16 meters squared. Now, this is how we solved it using the equation. You could have also solved it, now that we know the length and the width, I could have also solved it using an area model. So let's go ahead and show you the area model. So if I did an area model, I would have my 3/8 for my width, and my length, we're going to separate it into ones, and my fractional part 1/2. So remember our length. So now I can go ahead and do each section. I'm going to do 1 times 3/8, and 1 times 3/8 would give me 3/8 for this part. And then in this section I would have to do 1/2 times 3/8. We do 1 times 3 is 3, and 2 times 8 is 16. So this is my piece for that. Now I have to take both of these two fractions and I have to add them together. I can't add these together until I find a common denominator. So if I do my multiples of 8, 8, 16. I know 8 goes into 16 and 16 fits into 16. So 8 fits into 16, 8, 16 times 2. Do the same thing to the numerator. 3 times 2 is 6. 16 went into 16 once. 3 times 1 is 3. So now I'm left with 6 plus 3 is 9. And I bring over my denominator, which is 16. And as you can see, whether I use the equation or my area model, I get the same answer as 9/16. Okay, so that was question number 1. Okay. Now we're going to move on to question number 4. Now number 4 has many parts. So let's get started with question number 4. Some wire is used to make rectangles A, B, and C. Rectangle B dimensions are 3/5 larger than A, and rectangle C's dimensions are 3/5 larger than B. Rectangle A is 2 centimeters by 3.5 centimeters. So the only thing that we know for sure is that rectangle A has 2 centimeters by 3.5 centimeters. So let's draw our 3 rectangles. We have rectangle A, rectangle B, and rectangle C. Now the only information, remember, that they gave us is that rectangle A is 2 centimeters by 3.5 centimeters. But we can find the others because it said in order to find rectangle B, it said that the dimensions are 3/5 larger than A. So in order to find rectangle B, we are going to do the 3/5, and we have to add that to the dimension of A, which is 3 1/5. So in order to find the width of this one, I have to do 3 1/5, and since I'm adding 3/5 more, when I add these, I end up with 3. 1 plus 1 is 4 over 5. So the dimension of B is 3 4/5. Because all I did is I added 3/5 to A. Now I have to do the same thing to the top. To the top, I have to add the 2 plus the 3/5. And when I add 2 plus 3/5, I end up with 2 3/5. So now I have my length for B. I'm going to do the same thing for C. C says I have to add 3/5 to B. So B had 2 3/5, and I'm going to add another 3/5. So that's going to give me 2 6/5. I can't leave 6/5 as improper, so I'm going to change 6/5. 5 fits into 6 one whole time, and that leaves me with 1 left over. But now I have to add these two pieces together. So 2 plus 1, that gives me 3 1/5. So 3 1/5 is my length for C. And then I have to take my 3 and my 4/5, which is what the width of B was, and I also have to add 3/5 to it. So 3 plus nothing is 3. 4 plus 3 is 7 over 5. Again, the 7 is improper. 7/5 is improper. 5 fits in the 7 one whole time with 2 left over. So now I have to put my two whole numbers back together. That would give me 4 2/5. So my width is 4 2/5. Okay, so that was just to find the rectangle's widths and their lengths. So now that we have all of our pieces, we have our length and our width for A, our length and our width for B, and our length and our width for C. Now that we have all of those pieces, now we can go ahead and find the areas for each rectangle. So we're going to find the area for A. And in order to do that, we have to do length times width. So it's going to be 2 times 3 1/5. And what I'm going to do is I'm going to put the 2 over a 1. So I have fraction times a fraction. And then I'm going to change this mixed number into improper. 5 times 3 is 15. 15 plus 1 is 16. So now I have 2 over 1 times 16 over 5. Okay. I have length times, I have my numerator times my numerator, and my denominator times my denominator. So I have to do 16 times 2. 2 times 6 is 12. Carry my 1. 2 times 1 is 2 plus 1 is 3. That leaves me with 32/5. 32/5 is improper. So again, I bring it down here, and I'm going to have 32 divided by 5. 5 fits into 32. 5, 10, 15, 20, 25, 30. It fits in 6 times. 6 times 5 was 30. Subtract. I have 2 as a remainder over 5. So that's equal to 6 2/5. That is the area for letter A. So my area for letter A. Okay, now we're going to go on to letter B. Letter B has, I'm going to put it on this paper because it's going to be very messy if I don't. So let me show you B. In order to find the area for letter B, we're going to do the same thing. We have to do length times width. So we have 2 3/5 times 3 4/5. I'm going to change both of those into improper numbers. 5 times 2 is 10. 10 plus 3 is 13 over 5. Then I'm going to change this one. 5 times 3 is 15. 15 plus 4 is 19. 19 over 5. Now I'm left with numerator times numerator, denominator times denominator. So I'm going to take the 13 times 19 first. 9 times 3, 27. Carry my 2. 9 times 1 is 9. Plus 2 is 11. So I have 117. I'm done with the ones place. So I'm going to cross those out. I'm going to be multiplying in the tens place, so I have second row I have to hold with a 0. 1 times 3, 3. 1 times 1, 1. Add them both up. 7 plus 0, 7. 3 plus 1, 4. 1 plus 1, 2. So the 13 times the 19 gave me 247. And then denominator times denominator is 25. So I can't leave that improper. So I'm going to take my 247 and divide it by 25. So I have 247 divided by 25. Put it up here so you could see it. 247 divided by 5. Well, 25 does not fit into 2. 25 does not fit into 24. So I have to put it into 247. So I'm going to go ahead over here on the side and do my 25, my multiples of 25. So I have 25, 50, 75, 100, or 4 quarters is $1. 125, 150, 175, $2, and then 225. If I go to 250, that's too much. So I'm going to stop at 225. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 225 fits into 247 9 times. And 9 25s were 225. Subtract. 7 minus 5 is 2. 4 minus 2 is 2. So it fits in there 9 whole times, 22 left over, and my denominator is 25. So my area for letter B was 9 and 22 25ths. Okay, so that was for letter B. Now we're going to go ahead and do letter C in the same way. I'm going to use another sheet of paper so you could see letter C. So letter C, we're going to do the length times the width. So for area for letter C, our length was 3 1/5, and our width was 4 2/5. Okay? I'm going to change my mixed number into an improper fraction. 5 times 3 is 15, and 15 plus 1 is 16 over 5. I'm going to do the same thing with my second number. 5 times 4 is 20 plus 2 is 22 over 5. So now I have to do numerator times numerator, denominator times denominator. I'm going to do 16. 16 times 22. 6 times 2 is 12. Carry my 1. 2 times 1 is 2 plus 1 is 3. Done with the ones place. Since I'm multiplying in the tens place, I need a 0 to hold my spot. Raise this up a little so you can see. 6 times 2 is 12. Carry my 1. 2 times 1 is 2 plus 1 is 3. So I have both partial products. I'm going to add them together. 2 plus 0 is 2. 3 plus 2 is 5. 3 plus nothing is 3. So I have 352. That would be my numerator. So 352. And my denominator is 5 times 5, which is 25. I have an improper fraction, so I have to divide 352 by 25. So I start at the beginning. Does 25 fit into 3? No. Does 25 fit into 35? Yes. 25 can fit into 35 one time. 1 times 25 is 25. 5 minus 5 is 0. 3 minus 2 is 1. Bring down the 2. How many 25s go into 102? Well, if I skip count by 25, 25, 50, 75, 100. 1, 2, 3, 4. It fits in 4 times, and 4 times 25 was 100, with 2 left over. So 25 can fit into 352. It fits in 14 times, and 2 over 25. So that is my area for letter C. So area for letter C. So that was a lot of work, but we're still not done. Because now that we have our area for all 3 rectangles, I need the total area. So in order to find the total area, I'm going to take my area for letter A, my total area for letter B, and my total area for letter C, and I have to add them all together because it says total area. So in order to find my total area, area A was 6 2/5 of a centimeter. Letter B was 9 22/25. And the area that we just found for letter C was 14 2/25. So let me double check to make sure we have all 3 of our areas correct. Area A was 6 2/5. Letter B was 9 22/25. And letter C was 14 2/25. So the total area, I need to add all of these together. Now, in order to add these together, I need a common denominator. And these 2 are common, but 5 is not. So I need to change 5 so it has a common denominator. And if I do my multiples of 5, 5, 10, 15, 20, 25, I notice that 5 does go into 25. What did I multiply 5 by to get 25? Well, 5 times 5 is 25. And whatever you do to one, you have to do to the other. So 5 times 2 is 10. So now I just made an equivalent fraction. 6 2/5 is the same as 6 10/25. So now I'm just going to bring over the rest of my numbers so that I can add them, because now the denominators are the same, so I just have to add them up. So the first thing I'm going to do is start with my whole numbers. 6 plus 9. 6 plus 9 is 15, and 15 plus 4 is 9. So we put down my 9. And since I had 19, so we got 19, carry your little 1. Don't forget that little 1. 1 and 1 is 2. So my whole numbers are added up. Now I have to add my fractional parts. I'm going to do 2 plus 2 is 4, and 1 plus 2 is 3. So I have 34 over 25. 34 25ths is improper, so we have to fix it. 25 fits into 34. So let me show you down here. 25 fits into 34 one time. And when I subtract, I can't subtract 5 from 4, so I go back to the 3 to regroup. 4 becomes 14. 14 take away 5 is 9. 2 take away 2 is 0. So I end up with 1 and 9 left over, my denominator of 25. So 34 over 25 is equal to 1 and 9 25ths. So don't forget now to add your two whole numbers together. So I end up with 29 plus 1 is 30, and my 9 25ths. And don't forget your unit, centimeters cubed. This is my total area for all three rectangles, 30 and 9 25ths. And yes, that was a lot of work to find the area. We had to find the area for each rectangle first, and then we had to add them all together. So that is just part A. Now we have to go on to part B. So let me take all of these down. So part B says, do this first. It says, if a 40 centimeter coil of wire was used to form the rectangles, how much wire is left? So here are my three rectangle boxes, A, B, and C. So they took this coil of wire and they wrapped it all the way around to form these three rectangles. They wrapped it all around. They want to know how much wire is left from this 40 centimeter coil. Now, we already went through and we found the length and the width of all of these. We had A was 2 centimeters by 3.5. And then we added 3/5 to that, and we came up with 2 3/5 and 3 4/5. And then we added 3/5 to B, and we ended up with 3 1/5 and 4 2/5. Okay, so those were the measurements that we already had from part A. We found the length and the width. But now they're asking us to find how much wire went around each box. And then of that 40 centimeter coil of wire, how much is left when we were done doing that? So since we're going all the way around, now we're going to be looking for the perimeter because we want the distance all the way around. So in order to find perimeter perimeter, remember, is the distance all the way around, and that's found by adding the side plus the side plus the side plus the side. So it's side plus side plus side plus side. So let's figure out the perimeter for A. For letter A, for the rectangle A, I have 2. Well, remember, if this length is 2, then this length is also 2. And if this length is 3 1/5, this length would also be 3 1/5. So I have 3 1/5. So in order to find the perimeter for A, I have to go ahead and add all of those sides together. I'm going to do 2 plus 2 is 4. 4 plus 3, 7. 7 plus 3 is 10. And then I'm left with my fractions. 1 plus 1, 2/5. So my perimeter for A is 10 2/5. Okay, let me go on to letter B. Letter B has 2 3/5. 2 3/5. Remember, if this is 2 3/5, this is also going to be 2 3/5. So plus 2 3/5. And if this is 3 4/5, this is also going to be 3 4/5. So I have to go ahead and add up all those sides. 2 plus 2 is 4. 4 plus 3 is 7. And 7 plus 3 is 10. Now I have to go ahead and add my fractions. All of the denominators are the same, so I just have to add the numerators. 3 plus 3 is 6. 6 plus 4 is 10. And 10 plus 4 is 14. Bring over my denominator. So I have 10 14/5. I have to change this 14/5 because it's improper. 5 fits into 14. 5, 10. It fits in there 2 times with 4 left over. So now I have to put back these 2 whole pieces. That gives me 12 4/5. There is my perimeter for letter B. Now I'm going to go ahead and move this up. Now we're going to do letter C. The perimeter for letter C, I have 3 1/5. If this is 3 1/5, so is this, plus 3 1/5. If this is 4 2/5, so is the other side, 4 2/5, plus 4 2/5. I'm going to add all the whole numbers together. 3 plus 3 is 6. 6 plus 4 is 10. And 10 plus 4 is 14. My denominators are all the same, so I have to just add my numerators. 1 plus 1 is 2. 2 plus 2 is 4. And 4 plus 2 is 6. My denominator was 5. This is improper, so I need to change that. 5 fits into 6 one whole time with 1 left over. Okay, so now I have to put my 2 whole numbers back together, and I end up with 14 plus 1 is 15. Add these 2. And then 1/5. So my perimeter for letter C is 15 1/5. So first I need to find the total perimeter of how much of the coil that I used. So by finding all the total perimeter, I have to add all of those up. So my total perimeter would be 10 2/5 12 and 4/5, and 15 and 1/5. I add them all up. Now, if you take a look, all the denominators are already the same, so I can go ahead and add them the way they are. So I'm going to do the whole numbers first. 5 plus 2 is 7. 1 plus 1 plus 1 is 3. And now I'll go ahead and do my fractions. 2 plus 4 is 6, and 6 plus 1 is 7. My denominator is 5. This, again, is improper. We've had a lot of improper. So I have to divide 5 into 7. 5 fits into 7 one whole time. That would leave me with 2 left over. Now I have to add my 2 whole numbers back together. That's going to give me 37 plus 1 is 38, and 2/5 centimeters squared. That's how much of the coiled wire that I needed to wrap around these 3 rectangles. So that's my total perimeter. But they're telling me that the coil had 40 centimeters of wire on it. So if I had 40 centimeters of wire on the coil and I used 38 and 2/5, I want to know how much is left. Now, in order to find out how much is left, that means I'm going to be subtracting. So I can't subtract 2/5 from nothing, so I have to go over to the 40, and I'm going to regroup it by taking 1 away, so that will make it 39. Now the one that I took away, I can change into any fraction that I want, as long as it's still equal to the one that I took away. And since this fraction ends in a 5, I'm going to take that 1 and change it into 5/5, because 5/5 is still equal to the 1 that I rebundled, and I could subtract it from my 2/5. So now my equation is ready. 5 minus 2 is 3/5. 9 minus 8 is 1. So I will have 1 3/5 of the centimeter wire left when I'm all done. Wow, that was a lot of work for one question. We reviewed how to find area, and in part B, we also reviewed how to find perimeter. Did a lot of fraction work. I hope this helped you. Please complete the exit ticket for lesson 15. Then take a picture and send it to your teacher so we can see how you're doing. Thanks for listening. Bye.